First, I would like to demo a tool that we're building at HOPR, which is called DERP. And yeah, so in this session, I'll take you through DERP, highlighting a severe privacy issue on Ethereum. And in fact, this is not just related to Ethereum. So the privacy issues that I'll be talking about in the next 20 minutes or so are in fact the same on all blockchains. And what is kind of interesting is that these issues that we'll be talking about also affect so-called privacy chains, because the thing that HOPR is tackling is actually not on-chain privacy, but transport privacy. So that's something that is basically involving data transfer before your data is even hitting any chain. Can you guys see my screen well?
Yes.
Cool, we got that to work now. Nice. So if you navigate to derp.hoprnet.org, you can basically play along with what I'm doing here. So effectively on the website, what we will see is that we mirror your RPC requests that go through your wallet. So basically, DERP is visualizing everything that your wallet is doing. So I find this extremely educational and sometimes also insightful when I want to find out how a particular wallet is doing things, and when I want to find out what my RPC provider actually knows about me. Now, quick recap, what are these words like wallet and RPC provider? Like your wallet, I think is kind of clear, right? Your wallet is what contains your private key that allows you to move your ETH, your ERC20 tokens, such as HOPR, your NFTs, and whatever you might have. So the wallet that I will be demoing is MetaMask, but you can use DERP from any wallet you like. I also personally like Frame, so 0x Frame or frame.sh. You can use any Ethereum wallet that you like on a bunch of chains. So let's get started checking out what DERP can do. So effectively, if you scroll down on derp.hoprnet.org or just hit the setup button, you will find instructions that you can add to your MetaMask, and we'll walk through that in a second. And down here, we see basically an empty table header, and this table will get populated with requests that your wallet is sending to the RPC provider. So the RPC provider that by default is configured to be Infura is telling your wallet everything that it needs to know. Like your wallet is basically just this dumb piece of software that knows nothing. It relies on an RPC provider for everything that is going on chain. So your wallet knows your Ethereum address, but it doesn't know how much ETH you have, what your ERC20 wallet balance is, and it also cannot send transaction without the RPC provider. So in essence, this RPC provider is your gateway to the Ethereum blockchain. And now what we're changing is we're changing in the config the default provider, which I'll just open up my MetaMask up here. And we will change that provider to DERP. So you see up here, I'm connected currently to the Gnosis chain. I'm switching now back to Ethereum mainnet. But what we're going to do now together is we will configure the DERP provider. Okay, I'm going to use DERP on Ethereum mainnet. That sounds reasonable and applicable to a whole lot of DeFi and NFT use cases. So what you will do is you will open up your MetaMask. If you have a different wallet, you can try the same thing, but it will work somewhat differently. And the next thing that we will do is we will open your settings. Sorry, not settings, but you will open the network dropdown. So in the center of your wallet up here, you see Ethereum mainnet. I have already added Gnosis. That's why I see that here. You probably don't see that. And you hit add network. And you'll get a pop-up on MetaMask. We will actually not go through any of the pre-configured networks. We will add a network manually. So in my case, oops, sorry, wrong tab. In my case, I will just copy paste the URL. You can probably also hit the switch button here, but I'll do it manually. I'll call it DERP mainnet. I'll add the URL, and we need to fill in the other fields. So I will add the chain ID. Ethereum mainnet is 1. The currency, the native currency on Ethereum is ETH. So, if you're moving, for example, to Gnosis Chain, you would simply add XDAI here. Block Explorer is optional. I'll not enter that here. You can enter, for example, Etherscan. All right, so what is happening? Let's go back to DERP. What you see here, if you scroll down here, is that this table is no longer empty. We see that so far, there were 9 calls being made to this RPC provider in the last 30 seconds. And that's kind of interesting. I just connected my wallet, and there's a whole bunch of calls that are continuously being made by my wallet. So the next thing that you see about me is I'm based in Switzerland. I'm based in Zurich, which is correct. You see my IP address. So I'm fully doxed for all of you, right? So on top of that, which is what your RPC provider sees, you see all the requests that are going out. So I'm scrolling all the way down, and we will try to understand what my wallet, in my case MetaMask, is doing here. So the first request that was being sent out is an ETH chain ID. So this ETH underscore chain ID is basically your wallet saying, hey, RPC provider, tell me which chain I'm currently on. And in the response that is not depicted here, it will here you are currently running on Ethereum mainnet. It's basically a sanity check. And I have no idea why MetaMask is checking that 4 times in a row. And the response should be the same every single time, because currently I'm just connected to Ethereum mainnet, so chain ID will always return 1. The next thing that my MetaMask will ask its RPC provider is this ETH block number. So it's basically telling me, hey, what time it is, right? What time it is in blockchain terms means on what block number are we. I actually have no idea what net version is, what network version, maybe which fork we are on. I'm not familiar with this endpoint. And now it already starts getting pretty interesting. So right after my Ethereum wallet and my MetaMask was started and I configured DERP with it, it made this ETH call. And ETH call is basically a smart contract call. So we are calling a function on a specific smart contract. Let's try to understand what is going on over here. So first, like the easy part is finding out which smart contract is being called. It's this address here. So I'm just going to copy paste it. And maybe for you guys, this looks a little bit different, but we should pretty much see similar things. If you use a different wallet, maybe you don't see this call being made. So I'm going to etherscan.io, and I will copy paste the address that was shown in DERP. So again, I scroll down again. So this ETH call, the to address was what I copied. And I searched for that address on Etherscan. And if we check out the contract here, it's a smart contract, which is not surprising. It's a so-called balance checker smart contract. Now that is pretty interesting. Okay, let's see what it actually does there. So it's calling this function that is identified with 0xF022EA9. So that is in Ethereum called a function identifier. So the first 4 bytes, so 4 bytes means 8 digits after the 0x. So 1, 2, 3, 4, 5, 6, 7, 8. There is this scrolling behavior is tripping me off a little bit. So now the question is like, what is it actually doing here? Like, what function is this? This is not very human readable. But luckily, there is a reverse lookup where we can enter the function ID and it'll tell us which function are we calling here. So I will call this 4bytes.directory, which is just a very convenient database which shows you this function signature. So I will paste here this 0xF002E89. And it checks it calls actually a function called balances. And this balances gets a bunch of addresses. So what's actually, you could now, if you really wanted to know what's going on, you could try to find out here in the smart contract code what this actually does, this balances function. So in essence, I'll just translate this Solidity code here to simple English. It is getting a batch, so a list of Ethereum addresses, and it is checking token balances for each of them. Now, we will basically now analyze why is that a privacy issue. And for that, I will look at the payload data that DERP shows me. So by the way, you see that this ETH call is not just done once, but it's done all the time, right? So every couple of seconds, so this was at 12. So basically every 30 seconds, your MetaMask is calling this endpoint. And now what we're going to find out is what does it actually send. So again, all this information is being sent to your RPC provider. There's a whole lot of zeros. Every now and then there is a letter in there that is basically just the encoding that the Ethereum virtual machine is using. The EVM is not particularly efficient. Therefore, you see a damn lot of zeros that are prepending the actual payload data. And then eventually we see this FC something. Now, I'm skipping one here. Now, what kind of an address is that? Again, I will go on Etherscan and try to find out what kind of an address this is. It's an address that has only done one transfer, kind of weird. So if you actually, this will be a different address for you. So if you look at my MetaMask, you will find out currently I'm connected, like the account that I have here is the so-called HOPR Dev Bank. That's the account that we're using internally for funding deployments, for interacting whenever any of our devs are making some transactions for technical purposes. So it's clearly not that address. It doesn't start with an F, right? But if you check out what else I have here, I have another account loaded. And this other account is indeed FC2 and so on. So despite the fact that I was connected to my DevBank account, MetaMask was checking the balance of the other account, which isn't even connected. So this is the first thing which DERP allows you to find out, that here we have our first pretty damn solid, serious privacy issue. Because MetaMask is doing one request to the RPC provider, which is checking all my balances in one go, right? So in one go, it is submitting multiple Ethereum addresses in one go to the RPC provider. And now you might say, hey, you know what? Why is that an issue? And to me, this is a serious issue because I might have different accounts here which I do not want to be linked, right? So maybe one is my HOPR Dev Bank, the other one might be my private account. And the RPC provider knows that I control both of these accounts now, and both of these accounts are connected to my computer. And both of these are also tied to an IP address. So now somebody on the internet, which I don't particularly trust, like I don't even have any sort of understanding who I'm connected to right now, knows my IP address and knows all my Ethereum accounts which are connected to my MetaMask, only by looking at the payload data. Now, that's a bit an issue, which is an optimization issue that wallets sometimes do, and that's not great. Let's fast forward to an ideal world, right? Your wallet would not do all these ETH calls, which are submitting multiple balance checks for multiple accounts in one call. Still, you would have requests that are being made to an RPC provider, which all come from the same IP, right? So you see on top of this kind of now growing table that the same IP address, which shows you that I'm based in Zurich, is connected to all the accounts that I might use when I switch around here, right? So when I switch in my MetaMask, my account, you see that very rapidly right after there was another call being made. So all these calls disclose something about you. And DERP is pretty interesting when it comes to finding out what's going on. Let's do a second example. Let's check out what happens when I actually go on Uniswap. So we'll open app.uniswap. uniswap.org. And what I'm going to do here now is I will kind of show them next to one another so you can kind of follow what's going on. So I connect the Uniswap app to my MetaMask. It's asking for permission. MetaMask is taking a while. And I'll actually connect both accounts to Uniswap. All right, whole bunch of things going on. There's a bunch of additional ETH calls being made the second I connected myself to Uniswap. So let's try to understand what actually happened here. So again, initially we see a bunch of, I'm trying to find out where I was the first time connected to Uniswap. So we see again the usual ETH block number, the ETH call, and was somewhere a different address that popped up here. So what is going on here? We see another ETH call being made, but the payload that looks different here. So we are calling a different smart contract. Let's find out what's going on here actually. Again, I'm going to open EtherScan and simply paste the address. So this is again a smart contract, and this smart contract is called ENS registry with fallback. So probably many of you have heard about ENS. It's the Ethereum name service, similar to DNS. So you can register your name. So for example, we have HOPR.eth. I have my usual scburgle.eth, which I use on multiple social media profiles. So this is a convenient thing to do. But Uniswap, the second I connect to it, is querying this ENS registry contract. So let's think about if this is a privacy issue. In order to find out if this is a privacy issue, let's look at payload data that is being sent along. So it sends along, in this case, 0x01 and so on, which, let me open my wallet here, is none of my accounts. It is some other accounts. Okay, so in this case, this is not related to me. It is some other smart contract which it wants to know, okay, tell me what is the ENS domain of this one. There's some other apps which are simply checking an ENS registry, and even an ENS registry lookup is a privacy issue, right? Your RPC provider knows now that you were interested in a particular address on the Ethereum blockchain. Okay, so I'm just going to scroll way up here, and I'm going to continue interacting with Uniswap. So there's another call being made. Let's check out what's going on here. Okay, Uniswap interface multi-call. What is this one doing? This one is a bit complicated. I actually have no idea what it is. The Uniswap multi-call interface allows you to check multiple things on a smart contract in one go. So that's one thing that Uniswap allows Uniswap to more efficiently query data from the Ethereum blockchain. And yeah, so there's a whole bunch of things that are being queried by the Uniswap app that were not being queried before. If we look at this lengthy payload, it's kind of annoying that it just scrolls down, but we see this data with pretty much every single call here. B1, no, not this one. Here, 1F. Okay, I'm just going to full text searches. 1F. So if we look at this payload data, I'm just going to paste it in a Google Doc. Not logged in here, so I'm just going to look at it here. So we have a very lengthy payload here that is being passed. Yeah, kind of hard to tell what it does here, but it checks a bunch of things in one go. Okay, let's keep starting to swap things on Uniswap. I am going to pretend I'm going to swap ETH to, let's swap it to HOPR. And I'm going to pretend I have a tiny balance here, so there's not much I can do. I am going to do this swap. So this was kind of interesting also. You didn't see any pop-up here in the meantime while it was creating the balance. And that is interestingly also telling you something. Like Uniswap gets this data from somewhere, but it doesn't get it from my RPC provider, which means Uniswap is actually internally having a second RPC provider from which it is fetching data. And that also, in my eyes, is a pretty serious privacy issue because you're now exposed to an RPC provider that you know nothing about, which is querying all sorts of things about you. So I'm going to initiate this swap here. I'm going to say, hey, confirm. And a bunch of things are happening in my MetaMask. My MetaMask is doing, again, a bunch of calls in one go. It's doing an ETH get transaction count, which is basically checking the nonce, which is required for formatting the transaction, and doing a balance check again. So all of these things, it's also doing the 0x000. So we've seen before this was the ENS lookup. So it was checking, hey, are you actually currently sending something to an ENS contract? Yeah, what else does it do here? Oh, there's another smart contract. Let's check out what this one is. Yeah, this is the Uniswap router. So basically, this is pretty interesting. My MetaMask was calling a function on the Uniswap router before I even submitted a transaction. And that is kind of revealing because sending something to the Uniswap router reveals what you're about to do. 0x68. And the data that it submits here is probably against some obscure Uniswap function. So now your RPC provider knows, hey, this user is about to use Uniswap. And yeah, that can be used against you, of course. We've all seen how MEV, so maximally extractable value, is a multi-billion-dollar industry where people are trying to front-run you and are doing increasingly sophisticated attacks in order to find out from you what is going on. Now, here we have a new angle to MEV. An MEV searcher, which is trying to front-run you, will effectively know what I'm going to trade before I have submitted my transaction. And that's kind of profound because normally what MEV searchers do is they see a pending transaction in the mempool. They figure out, hey, what's this transaction actually doing? For example, swapping some ETH to HOPR and then trying to front run me, right? So trade ahead of me in order to get a better price for themselves and a worse price for me. With this information on the RPC provider level, they can see what is going on and use that against me. So I will again look for this smart contract because you could see actually a whole lot what I'm about to do here. So we see that we are submitting to this smart contract. We are actually submitting. Let me quickly open up an editor to look at its payload data. Yeah, you're seeing basically what function I'm going to call, and that's a bit more, right? So this is not just the function I'm going to call because it has more than 4 bytes. So yeah, that reveals some information of what I'm going to do in Uniswap. Cool. So you can see that through DERP, we could find out that even ahead of me submitting a transaction, there's a whole lot of information that is leaking to the RPC provider, and that information is tied to my IP address at all times. I will stop the presentation of DERP here and move on for a minute to RPCH. So in summary, we've seen with DERP that there's a whole lot of calls being made. So I have here like 256 calls in like 20 minutes, and I didn't actually do anything, right? I didn't actually do any trades. This is just kind of getting ready for doing something on chain. So there's 260 calls revealing something about me without actually having done anything on chain. Now, how can we get better than that? How can we fix this serious privacy issue that information, even before it hits the chain, is being leaked to an RPC provider in a fashion that can be tied to my IP address, my hometown, and other metadata information to my location and my computer that I'm currently using. And the thing that we've been working on is called RPCH to solve exactly this issue. We announced it for the first time right around DEF CON when we were in Bogota, and we announced that we would work on RPCH. RPCH stands for RPC over Hopper. So all these calls which we've been analyzing in plain text and which could be tied to metadata information such as my IP address can be sent through the Hopper mixnet. Why would you do that? Because the server which receives your request will have no way of finding out where this request actually originated from. So they see the so-called exit node, and I'll switch to on to the RPCH page. So on our website, we have a little architecture overview. So this here is your wallet, right? And we're now fast forwarding to a version of a wallet that is much more private than wallets are today, thanks to Hopper. So the crypto wallet that is actually privacy enabled will have our RPCH SDK integrated. And people might ask, hey, why do you need this SDK? And we need this SDK because normally your wallet only speaks a very simple language that is called HTTP, just like websites, right? So your wallet is sending requests that we just looked at via the HTTP protocol. And typically that is secure. That's what HTTPS stands for, but it's not private. So effectively, with integrating RPCH and Hopper into wallets, we're making crypto wallets not just secure, but also private. In other words, your crypto wallet needs to have this little bubble fish, which allows it to understand the language of Hopper and not just the language called HTTP. And that's since wallets don't do that natively, they need to integrate our SDK. Once we have that, requests are being sent through the Hopper network until they hit an exit node, which is taking the request, sending it to an RPC provider that is basically just running a bunch of Ethereum nodes. If you're connected to mainnet, it runs, of course, a mainnet Ethereum node, such as Geth, Go Ethereum, or on Gnosis chain, for example, we would run Nethermind, just as an example of an execution layer client that is serving the responses to these requests. Then after the request has been sent here and you get a response from the server, the exit node is sending information again through the Hopper network back to the entry node, which sends it back to your wallet. Now, this sounds a bit complicated. Why do we have to make it that complicated? Because we want to unlink the crypto wallet on the one side from the RPC provider on the other side. And thanks to the Hopper network, we have full metadata privacy between the wallet on the one side and this RPC provider. So that is something that we're currently building. Development of RPCH is currently ongoing. And I think I can say here that the first wallet that we will onboard is Block Wallet. Block Wallet is a privacy-focused wallet. Great people who are building it, very privacy-focused. They used to have a Tornado Cash integration. Unfortunately, they felt too much heat and they took that out. And therefore, the Block Wallet team is pretty interested in adding another layer of privacy through Hopper. So that is integration with wallets. So if there's more folks here who work for wallets and are interested in working with us on also having a wallet that speaks the language of privacy, please come talk to us. We are happy to, integrate RPCH into as many wallets out there because we at Hopper want to make the whole Web3 private and secure for everyone out there. So yeah, there's a contact form on the website. If you're interested in that, please contact us. So it's on the wallets page. Yeah, we have a contact form. So please contact us there. We're very eager to integrate RPCH into as many wallets as possible. that want their users to be secure from data harvesting by RPC providers. Now, there's a question here that a bunch of people are confused about. They're saying, hey, Sebastian, this is great. I want this. Like, why do you need to go this route via a wallet? Like, why can I not, as an end user, just like run this thing myself? So, and the short answer is we're working on enabling you to do that as well. So basically, if you are interested in running RPCH yourself before your favorite wallet has integrated RPCH, you will need to install software on your computer. It's not going to be as convenient because you just need to install something. And again, why do you need to install something? So that your wallet can understand or have this translating unit that translates HOPR traffic into HTTP traffic that your wallet runs. So in essence, for the more technically inclined folks here, this software that you will be running locally on your computer is running a local web server that serves the requests for your wallet. And on the other end of it, it is talking to an RPCH entry node to send data through the HOPR network. So on the one side, it speaks HTTP for your wallet. On the other side, this connector is basically speaking HOPR facing the HOPR entry node. So we're working on that. And yeah, there is a pre-registration form. I don't know if it's linked somewhere, but it's RPCH/self-integration. So if you're interested in that, please pre-register now. We have a Google form here where we ask you a few things. We're asking you like how busy you are, how frequently you are using your wallet. And yeah, maybe if you sign up there, you might find yourself being one of the first users of RPCH. So again, if you're a wallet, please contact us. If you are an individual that would like to use RPCH, go through the pre-registration form and let us know that you're interested in it. We will get back to you as soon as we have an early version that you can play around with. And finally, we are interested in privacy, but that's not all. We want to make the Web3 a safe place for everyone. And therefore, we are also looking at solutions that increase the security and the trust assumptions of your wallet. So currently, actually, your DERP endpoint could give you any data. It could tell you that you have 10,000 ETH, and your wallet would actually think, oh, I actually have 10,000 ETH. And there's no way of checking that this information is correct. And that's the second thing that we're tackling here. So we are currently actively looking at two solutions called Helios and Kevlar in order to integrate them into HOPR. And what that would gain you is that if there's an RPC provider which is giving you bogus data, it would basically not succeed. So this RPCH SDK would figure out that, oh, actually, this information that I just got is bullshit. I don't actually have 10,000 ETH. That RPC provider is trying to play a nasty game. So that's the second thing that I'm pretty excited about, that we make wallets not just more private, but also improve the trust assumptions of wallets. And final note, for wallets that are interested in working with us, we're part of a hackathon end of April in Istanbul. If you're interested in hacking on integrating RPCH into your wallet and be the first wallet that integrates RPCH SDK into a wallet and make your users be much more private, then yeah, please contact us and we will gladly invite you to Istanbul and hack with us on making crypto wallets more private. Good. That was my a little bit lengthy presentation of the problem that you can hack and find out with DERP and the solution that we're building with RPCH. If there's some more questions, I'm happy to answer them in the last couple of minutes that we have here. And otherwise, I'm happy to also answer them later on Telegram. Good. So we have a question from some random guy. Could you expand on the risks of an RPC provider feeding you false information? What could they gain by doing this? Absolutely great question. So there's a number of attacks that you could imagine. So first one is that they could simply feed you like wrong information, which is just not nice, right? But some information that is interesting is, for example, if you're trading on a DEX, and if I'm feeding you wrong information, you might, let's say you're trading some token and you're an active trader. What could happen is that somebody is feeding you bullshit price information. You're seeing that the price is going massively up or down, like you're thinking, oh, there's this massive dump, and you're panicking and selling all your tokens, right? And that is the combination of decentralization and kind of poor trust assumptions are pretty bad here. So on DEXs specifically, that is an issue. The other thing that you could imagine is, let me try to come up with another example. If you are trading, for example, NFTs, what you could have is effectively a man-in-the-middle attack by somebody who is pretending to buy from you and shield a better offer from you. So let's say you bought some NFT, and now there is somebody making an insanely good offer for you. I could kind of man-in-the-middle attack you and pretend there is some price that you're willing to sell it, but not as good as this other person is willing to make. And then I can basically, it's kind of like MEV, right? So I can basically shield the really good offer from you, make you an offer that you're hopefully willing to pay for, and forward and pocket the difference in price. So that is just some examples. There's like some really bad ones when it comes to OTC deals. I am just pretending to be somebody else. But yeah, these are maybe a little bit more niche. Any other questions? Good. Then again, sorry for the technical hiccups we had getting started here. Yeah, and thank you for joining us on this Google Meet. Happy to answer more questions at any time on Telegram on how we at HOPR are seeking to make Ethereum wallets much more private than they are today. Thank you so much, and have a good evening, everyone. Bye-bye.